Well, this video here is a summary of the article Introducing Electric Bus Fleets in Rio de Janeiro City, Methodology and Analysis, which was published in IEEE Latin America Transactions of the authors Caio Gonçalves da Silva e Silva and Luiz Arthur Pecorelli Pérez. So, this work proposed a methodology and analysis for the electrification of public bus fleets. And the new methodology developed shows a calculation process of necessary recharging battery stations and respective daily electrical demand curve behavior in order to establish future contracts with power energy distribution companies. The methodology was applied to a route with a tourist characteristics in the city of Rio de Janeiro. There are relevant reasons for the road transport electrification in Brazil. Two of them are: first, in fact the sector is responsible by practically 31% of energy consumption in the road count, as you can see in the graph. Second, in contrast, the production of electrical energy is clean and favorable to transport electrification because hydroelectric power is predominant in the country and there is an abundance of wind and solar potential to be explored. Seeing this, the article presents the bus fleet's operational analysis and the electrical network behavior in order to establish the demand curve at the terminals along the road and in the garage, energy consumption, respective cost requirements, and atmospheric emissions. About the methodology, the first step was to determine the energy consumption rate of each bus. For this, the PANVAC program was used. The variables used as inputs to the program were number of passengers, weight and load of the bus, the real driving cycle, and the traction equations. So, after obtaining the estimate of the energy consumption rate of each bus, it was possible to perform several analyses, such as energy consumption by bus routes, battery state of charge calculation, number of charging station evaluation, bus fleet active power demand, recharging electric energy costs, electricity and diesel cost comparison, and atmospheric emissions avoided. Results. Here we can see total daily distance traveled and electric energy consumption by each vehicle. Here are the demand curves. And as we can see, the peak demand of the fleet happens during loading in the garage, which is about 408 kilowatts. During the operation, the peak demand at each charging terminal is 160 kilowatts. Here we have the comparison of monthly operating costs between diesel and electricity. As we can see, the energy expended per kilometer is much lower when using electric energy compared to diesel. This is also reflected in the cost per kilometer of which propulsion systems, where electric propulsion is more advantaged. Uh, in this study, as you can see, an extrapolation was also carried out based on the data from the fleet of Line 100, considering the entire fleet in the city of Rio de Janeiro. In these graphs, we can see the atmospheric emissions avoided monthly if there is an electrification of Line 100. An estimate of avoided emissions was also carried out if the entire bus fleet in Rio de Janeiro is electrified. And finally, as conclusions we have. So, this new methodology established the parameters for contracting the supply for recharging the electric buses on a daily, monthly, and annual basis. The benefits of employing electrical power are self-evident. Despite its higher cost per energy unit, the great efficiency of this option over the use of diesel has provided expressive operational savings of approximately 16.84%. Line 100 electrification avoided at least 153,000 kilos of fossil carbon dioxide monthly atmospheric emissions and 1,845 tons yearly. So, the authors thank you for your interest in this subject.